In this recording, we're going to go through some of the algebra that you're going to need for the quadratics connection project. So you have your vertex form of your equation that you were given. And one of the things we need to do is convert it into what's called standard form. So standard form looks like this. Okay, has the a, the b, and the c that we utilize in the quadratic formula. So what are some things you notice about what is the same and what's different with vertex form versus standard form? Hopefully you recognized, hey, there's a square that's the same, there's an x that's the same, but there's no parentheses in the standard form. So really what we need to do is get rid of those parentheses. Now, there's three operations basically we need to do, which is square this binomial. We've also got the negative here, and we have a plus 5. We're going to do those operations in that order because we have to do our exponent first, and then our multiplication, and then our addition. So let's go through that. First, I need to multiply out this x minus 7 squared. So basically what that's saying is multiply x minus 7 times itself. Okay? But I still have the plus 5, and I still have a negative in front. Okay, so if I'm to show that, one way to do it is to create the area model. So x minus 7 times x minus 7. We can set up a box or a window. Okay, so why don't you work that one out and see how far you can get with that. Play the recording when you're ready. Okay, hopefully you paused and worked this one out. Okay, so those are our 4 terms. But really, all of that is still negative, right? And then we have a plus 5 on the end. Okay, so we're making progress, but we haven't quite got it there. Let's continue. Now we can just combine our like terms in here in the blue terms. We've got an x squared minus 14x plus a 49. Don't lose track of the negative sign or the plus 5. Now, what happens next? Do we multiply by the negative 1? I guess you could put a 1 here. Or do we add 5? Hopefully you're responding to me that you should multiply by negative 1. So let's distribute that negative 1 to all the terms. All these terms got to be opposite. Now we just need to combine like terms, the numbers. So our standard form is going to look like this. Okay, so there's lots of moves we made in this process. There's a lot of little places we could have made mistakes, and a little mistake is going to really have a big impact as we proceed to solve the equation. So we want to make sure we have the right equation before we compound our mistakes. So grab your graphing calculator, and what we're going to do is enter our vertex form equation in y1 and our standard form in y2, and then we're going to confirm that they're the same by looking at the table. Okay, so I've got the two forms. Now I just go to second graph and look at the table. Because the table has the same y1 and y2 for all the x's that I see, I'm pretty confident those equations must be the same. Okay, so we've checked that. Now we can proceed. The next task we have is to solve the equation by using the quadratic formula. Okay, so our quadratic formula one more time. Okay? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. All right, there's our quadratic formula. Yes, you have to sing it. Let's identify the a, the b, and the c values, those parameters from our equation. Okay, so again, we talked about y equals ax squared plus bx plus c. So the a is the coefficient of x squared, b is the coefficient of x, c is the constant. So a is a negative 1. It's the number in front of x squared. You could write a negative 1 in there. And c is negative 44. my strong suggestion, the suggestion of a lot of my colleagues, is to evaluate this discriminant first. Okay, this quadratic formula looks very complicated. Let's break it down into two manageable parts. The discriminant is the part under the square root. Okay, so we're just going to make substitutions. You don't have to put them all in parentheses if they're positive, but there's really no drawback, so I'm going to put them all in parentheses. Then just do this math. You can do it in your calculator, you can do it in your head. It works out to be 20. Okay? Now when I come to the quadratic formula and I start to write it out, I've got x equals opposite b, so that's negative 14, plus or minus the square root of this thing, which I've circled in blue, which is what we just worked out to be, 20, all over 2a. So just do the 2a in mental math. 2 times whatever your a is going to be easy for you to do in your head, negative 2. Before we proceed, what I'd like to do is find out what you already know on your project, which is what are the x-intercepts approximately. So I'm going to clear this second one out so we only see the one. You've already done this on your project. You've made the graph. So let's check out this graph and see where approximately our intercepts are. Okay, so I'm looking at this graph, and where I see across the x-axis, let's see, 1, 2, 3, 4, almost 5. I'm saying like 4.7, all right? 5, 6, 7, 8, 9, and a little more. I'm saying like 9.3 or something like that. Okay? So I'm going to come back over here and just write down my estimates over here. Estimates for x-intercepts from the graph. Okay, so we had said like 4.7-ish and 9.3-ish. Okay, so you already have those numbers in your head. You might have such an equation that they are exactly on the integer values, or you might have seen those on the table, those places where y equals 0, or you might have numbers that are not exactly on the table. So it's like in between two integers, and that's the case we have here. So now we just need to go to our graphing calculator and evaluate this expression here. So you're going to go to your home screen. You're going to go alpha, y equals, create a little fraction. Okay, we're going to do negative 14 plus the square root of 20 all over negative 2. Okay, I thought it was going to be like 4.7. Turns out it's really close. It's like 4.8, right? To copy and paste this, just cursor up on top, hit enter. You got the exact same thing. We just want to change our plus to a minus. That's going to give me the other root. Okay, so we'll hit enter. Bingo, I thought it was like 4.3. Well, I was not too far off. It was, 9.3. It was 9.2, right? It was pretty close. So those are my roots. I'm going to just put that into the note here. Okay, so if I were to round these answers off, I would say that my rounded answers are to the nearest hundredth place, 4.76, 9.24. And again, I'm using these kind of rounded braces because these are a set of x values. It's not an x and a y. All right, the last thing I need to do is I need to check these algebraically. So I can go back to either form of my equation. I'll go with the standard form. Okay, what I want to know is when the y value equals 0, because that's where my x-intercepts are, right, on the graph, where the y equals 0. So I'm going to make substitutions for those two values that I got. Remember, the two values that I got were, so I'm going to do a check by substitution. Okay. Now, I'm going to do this on my calculator because it's not something I can do really easy in my head. They're not nice integers to work with. So I'll do this on my calculator. Just get in your home screen. Too many 4s. Let me clean that up. Okay, it did not come out to be 0, but it came out really close, right? It's like negative 0.02. It's super close. So I'm going to say that's approximately 0, right? Okay, that's close enough because of the squaring of the rounded answer, okay? So it's not going to be exact. And I need to check the other root. So I'm just reading right from my equation, but where I see x, I'm making a substitution of this x. Calculator. Again, if I had used more decimal places, more precision, I would get something that's even closer to 0. And again, I get the same value. It's the same distance off from 0. So I can say that checks. Thanks for watching.